Assalamualaikum and hi everyone. We continue our lecture on redox reaction. So, what is redox reaction? Redox reaction is a type of chemical reaction that involves reductions and oxidation process that occur simultaneously. Now, what is oxidation and reduction process? When reaction involves oxygen, the one that gained oxygen is said to be oxidized and reduced when it lost oxygen. For example, X gained oxygen, hence it is been oxidized. And oxygen gas lost one oxygen atom and became reduced. Combustion reaction always involve oxygen. When reaction involves hydrogen, the one that lost hydrogen is said to be oxidized and the one that accepts hydrogen is said to be reduced. In this case, X lost its hydrogen atom and became oxidized. The most common redox reaction involves transfer of electron. If an atom lost its electron, then it is said to undergo oxidation process. The oxidation number for oxidized atoms or molecules will increase and reduce when undergo reduction process. Oxidation number is the charge of an atom or ion or a molecule or an ionic compound. Example, X is a neutral atom, hence its charge is 0, therefore its oxidation number is also 0. And the same goes to X when it is oxidized to X2 plus and X2 minus. However, there is a special rule when determining the oxidation number of an atom in a molecule or an ionic compound. Note that the charge of a molecule or an ionic compound is equal to the total oxidation number of the atoms that form the molecule or the ionic compound. If X is hydrogen that attached to a non-metal A, for example HCl, then the oxidation number of X is equals to positive 1. If X is hydrogen that is attached to a metal atom such as NaH, then the oxidation number of hydrogen is negative 1. The oxidation number of oxygen is always negative 2. The oxidation number for all elements in group 1A is positive 1, and in group 2 is positive 2, and finally the oxidation number for the halogen atoms in group 7 is negative 1. To identify which atom is oxidized in a reaction, it is best to have all this information in a table. In this reaction, the initial oxidation state for X and A is both 0. But when X donates one electron to A, it will lose one electron and A will gain one electron. Hence, the oxidation number of X increased from 0 to positive 1, and the oxidation number for A is reduced from 0 to negative 1. Therefore, X undergo oxidation and A is said to undergo reduction process. Note that the oxidation state or the oxidation number for an oxidized atom increase when electron is transferred. When X is being oxidized, then A is called the oxidizing agent that removes electron from another reactant, which is X. Vice versa, the X is the reduction agent because it donates electron to A. Example for this reaction, we know that the initial oxidation state for magnesium and oxygen gas is 0. Remember that the oxidation state for magnesium that belongs to group 2A in the periodic table is always positive 2, and the oxidation state for oxygen is always negative 2. Therefore, we know that magnesium transfers 2 electrons to oxygen. Hence, magnesium is being oxidized by oxygen that acts as an oxidizing agent. Oxygen itself accepts the 2 electrons from magnesium that act as the reducing agent and became reduced. Note that since 2 moles of magnesium is involved in the reaction, therefore the actual number of electrons that has been transferred by magnesium and accepted by oxygen is 4. There are 2 ways of balancing redox reaction. First, by oxidation number method, and secondly, by ion electron method or half reaction method in acidic or in basic solution. Now let us balance the equation using oxidation number. First, let us identify the oxidation number for stannum and nitrogen before and after reaction. Why only stannum and nitrogen? Because the oxidation number for hydrogen and oxygen is already fixed. From the rules given, the oxidation number for hydrogen that is attached to a non-metal is positive 1 and the oxidation number for oxygen is negative 2. The oxidation number for stannum before reaction is 0. And the oxidation number for nitrogen before reaction is being calculated. Remember that HNO3 is a neutral molecule and its total charge is 0. By including the oxidation number for both hydrogen and oxygen, we get that the oxidation number for N is positive 5. Then we calculate the oxidation number for both stannum and nitrogen after reaction following the given rules, and we get the oxidation number for both stannum and nitrogen is positive 4. We realize that the oxidation number for stannum is increased and the oxidation number for nitrogen is decreased. Therefore, stannum has been oxidized and nitrogen has been reduced. Then we determine the number of electrons involved. We know that the oxidation number for stannum increased from 0 to positive 4. Hence, it lost 4 electrons. Whereas the oxidation number for nitrogen reduced from positive 5 to positive 4, indicating that it gained 1 electron from stannum. The overall electron transfer process can be summarized as follows. Now, ensure that the number of electron loss equals to the number of electron gain. Therefore, we know that stannum lost 4 electrons and nitrogen gained only 1 electron. Therefore, to balance the electron loss and the electron gain, we need to multiply the number of electrons at nitrogen with 4. And we include this in the reaction equation. And we get the overall reaction as the following. Finally, we balance the overall redox reaction. In half reaction method, each half reaction equation is separately balanced. It may occur in acidic or basic solution. First, let us balance the redox equation in acidic solution. For this reaction, first we divide it into separate half reaction. Then, we determine the oxidation number for both chromium and iodine before and after reaction. The oxidation number for chromium before the reaction is calculated following the rules given, and we get positive 6. And the oxidation number of chromium after the reaction is equal to its charge, which is positive 3. For iodine, we know that its charge before reaction is negative 1 and 0 after the reaction. Therefore, the oxidation number for iodine is negative 1 before the reaction and 0 after the reaction. We know that the oxidation number for chromium has been reduced from positive 6 to positive 3. Hence, chromium is being reduced in this reaction. On the other hand, the oxidation number for iodine has been increased from negative 1 to 0, indicating that it has been oxidized. Now, we have to balance each half equations by following these steps. First, we must balance atoms other than oxygen and hydrogen. Then, we have to balance the oxygen by adding water molecules. Then, we balance the hydrogen by adding H+ ions. Now, we need to balance the charge to ensure that the charge in both sides of the half equations are equal. By doing this, we can reduce the number of positive charge. In this case, we must first determine the total charge that present in both sides. In this case, the charge of the reactants are positive 12 and need to be reduced to positive 6 by adding 6 electrons. The same goes to the half equation of the iodine, where the 2 electrons should be added to the product to balance the charge at both sides. Now, we need to balance the number of electrons in both half equations. We know that iodine half equation needs to have 6 electrons to balance. Hence, we need to multiply the half equation of iodine with 3. No changes are made on the half reaction of chromium. Then, we put both reactions together and check that the atoms and charges are balanced. Now, let us balance a redox equation in a basic solution. Again, first, divide this equation into their respective half equation. And then, we assign the oxidation numbers for mangan and carbon before and after reaction. Following the given rules, we get the oxidation number for mangan and carbon before reaction is positive 7 and positive 3 respectively, and after reaction is positive 3 and positive 4 for both mangan and carbon respectively. We now know that mangan has been reduced and carbon has been oxidized. The same steps are taken in balancing the half equation for both mangan and carbon in basic solution. First, balance all atoms other than oxygen and hydrogen, followed by balancing the oxygen and hydrogen by adding water and H+ ion respectively. And finally, balance the charge in both half equation by adding electron. Later ensures that the number of electrons in both half equation is equal. Therefore, we multiply the half equation for mangan with 2 and 3 for carbon half equation, and we get a new balanced half equation. This half equation of mangan and carbon is then added together and check again whether the atoms and charges are balanced. In basic solution, there is another additional step where OH ion is added to cancel the H plus ion, where this H plus ion and OH ion will react to produce water. Finally, cancel excess water and check again that the atoms and charges are balanced. And we get a balanced redox reaction in basic solutions. Sometimes in a redox reaction, only a single substance that is been oxidized and reduced. This is called as disproportionation reaction. Example, in this reaction, after examining the changes in the oxidation number for both Na and Cl, it is noticed that only the chlorine atom undergo both oxidation and reduction reaction when the chlorine atoms combine with natrium to form NaClO4 and NaCl respectively. There are 4 common redox reactions, which are combination, decomposition, combustion, and displacement. Combination reaction is where 2 or more substances combine to form a single product. Example, the combination of Al and Br to form aluminium bromide. In this reaction, aluminium is found to be oxidized and bromine is found to be reduced. Hence, aluminium acts as reducing agent and bromine acts as the oxidizing agent. Decomposition reaction is the breakdown of a compound into 2 or more components. Example, the decomposition of NaH into Na and hydrogen gas. In this reaction, the hydrogen atom is oxidized and acts as reducing agent. On the other hand, nitrogen is being reduced and acts as oxidation agent. Combustion reaction is a reaction in which a substance reacts with oxygen, usually with the release of heat and light to produce a flame. In this combustion reaction of propane, we know that carbon gains oxygen and it is said that carbon is being oxidized, hence it acts as reducing agent. On the other hand, oxygen lost its oxygen atom and hence it is said to be reduced and act as oxidizing agent. In displacement reaction, an ion or atom in a compound is replaced by an ion or atom of another element. It can be divided into 3 subcategories: metal displacements, hydrogen displacements, and halogen displacement. In metal displacement, copper is displaced by zinc atom. In this reaction, it is found that oxidation number of zinc has been increased, hence indicates that it undergoes oxidation process, hence acts as reducing agent to reduce copper. In this hydrogen displacement reaction, the hydrogen atom of the water is displaced to the natrium atom, hence became oxidized. In this reaction, bromine is displaced by chlorine and became oxidized due to its oxidation state increase from -1 to 0. Titration is a tool to detect change in the oxidation state of the analyte and the titrant. An indicator is often used. A common example of a redox titration is treating an iodine solution with a reducing agent such as thiosulfate using starch as indicator. The blue color of iodine turns into a colorless solution when all iodine has been reduced. This is called as iodometric titration. Another example is the titration of potassium permanganate against oxalic acid. The purple solution that contains the MnO4 ions change to colorless when it is reduced to Mn2+. In this titration, the KMnO4 itself acts as indicator. Now let us balance the equation using oxidation number.